Definite integrals. When evaluating a definite integral by substitution, two methods are possible. One method is to evaluate the indefinite integral first and then use the fundamental theorem. For instance, using the result of example 2, we have the integral from 0 to 4 of the square root of 2x plus 1 dx equals the integral of the square root of 2x plus 1 dx on the interval from 0 to 4 equals 1/3 open 2x plus 1 closed to the power 3 over 2 on the interval from 0 to 4 equals 1/3 open 9 closed to the power 3 over 2 minus 1/3 open 1 closed to the power 3 over 2 equals 1/3 open 27 minus 1 closed equals 26 over 3. Another method, which is usually preferable, is to change the limits of integration when the variable is changed. This rule says that, referring to Rule 6 sidebar, this rule says that when using a substitution in a definite integral, we must put everything in terms of the new variable u, not only x and dx, but also the limits of integration. The new limits of integration are the values of u that correspond to x equals a and x equals b. Back to the text. Equation 6, the substitution rule for definite integrals. If g prime is continuous on open bracket a and b close bracket, and f is continuous on the range of u equals g of x, then the integral from a to b of f of g of x times g prime of x dx equals the integral from g of a to g of b times f of u du. Proof. Let big F be an antiderivative of f. Then, by equation 3, big F equals, big F open g of x is an antiderivative of f of g of x times g prime of x. So by part 2 of the fundamental theorem, we have the integral from a to b of f of g of x times g prime of x dx equals big F open g of x on the interval from a to b equals big F of g of b minus big F of g of a. But applying uh, fundamental theorem of calculus 2, capitals FTC 2, a second time, we also have the integral of g to the g of a, the integral from g of a to g of b times f of u du equals big F of u on the interval from g of a to g of b equals big F of g of b minus big F of g of a. Example 7. Evaluate the integral from 0 to 4 of the square root of 2x plus 1 dx using equation 6. Solution. Using the substitution from solution 1 of example 2, we have u equals 2x plus 1 and dx equals 1/2 du. To find the new limits of integration, we note that when x equals 0, u equals 2 open 0 close plus 1 equals 1, and when x equals 4, u equals 2 open 4 close plus 1 equals 9. Therefore, the integral from 0 to 4 of the square root of 2x plus 1 dx equals the integral of 1 to 9, from 1 to 9, of 1/2 times the square root of u du equals 1/2 times 2 over 3 u to the power 3 over 2 on the interval from 1 to 9 equals 1/3 open 9 to the power 3 over 2 minus 1 to the power 3 over 2 close equals 20 6 over 3. Observe that when using equation 6, we do not return to the variable x after integrating. We simply evaluate the expression in u between the appropriate values of u.